So far, in the first three sections, we've focused on integration as finding the area under the curve and the interpretation of distance. And now we're going to move more into algebraic techniques. So 5.4 will get some skill and drill type problems. But so far, when we've talked about an integral, let's say something like the integral of x cubed plus 1, and we've maybe done that integral from something like 1 to 2, and so far we've been able to draw a picture for that. And if you got the graph of x cubed plus 1 and you were working on the area from, what did I say, 1 to 2, so let's see, there's 1, there's 2. So that integral I've written up there can be interpreted as an area under this curve from there to there. So we're talking about this area right here. And when we work that out, we'd be getting area of this blue thing. So when we go ahead and work this out, we do recognize that x cubed plus 1 has an antiderivative or an integral of 1/4 x to the 4th plus x. The derivative of that would be x cubed plus 1, and we're trying to evaluate that from 1 to 2. So we plug in 2, which will give us 1/4 2 to the 4th plus 2. So that was all plugging in 2. And we subtract, same thing, plugging in 1 and make sure we get parentheses here. So plugging in 1 for both x's just gives you 1 for the x, so that'll be 1/4 plus 1, and then you can crunch that down. And let's see, what's that? 16, 1/4 of 16 is 4, plus 2, minus 1/4 and 1, so minus 5/4. And this gets a little number crunchy, which isn't that important, but we'll go ahead and finish it for completeness' sake. So we've got 24/4 minus 5/4, so like 19/4. Okay, and that's fine. I do want to point out, though, that part of the skill here, and this is a skill we'll try to develop, was just saying what's the integral of 1/3, x cubed plus 1. And there are a decent number of problems in your homework that don't put the 1 and the 2 on there, and they'll literally just say, what is the integral of x cubed plus 1 dx? And that'll be the entire problem. And when you answer that, you'll just say, okay, what would x cubed go back to? And you say that would be 1/4 x to the 4th. What would 1 go back to? And you'll say that'll be x. And now that we're doing this just in general, rather than with specific limits, we'll want to say, well, the function whose derivative is x cubed plus 1 could have been this, but there could have been a constant on the end. Those of you that took Calc 1, you remember that one worksheet where we did derivatives and then we tried to reverse them. And you couldn't tell if there was like a plus 42 on the end. But so to compensate for that in general, when we're not talking about a specific function and not talking about area, we'll just put a plus c on the end. And this is an easy thing for calculus students to forget to do in Calc 2. But when you're doing a general antiderivative that has no limits here or here, so that's what they call an indefinite integral, don't forget to put that plus c on the end, because now we're just looking for any function whose derivative is x cubed plus 1. And that could be 1/4 x to the 4th plus x plus 5 or plus 17 or plus 132. So put that arbitrary plus c on there. Okay, so a lot of this is going to come back to, let's see, let's get rid of that and that. A lot of that's going to come back to just knowing your derivatives so you can reverse them. This table is in your book. This is on page 406, and I would encourage you to get very familiar with it. Most of your homework problems are going to be doing one of these or putting something in the right form so that you can do one of these. So they're reminding you things like, that, sorry, let's get the right layer. They're reminding you things that, like cosine, when you integrate that, you get sine. And you get a plus c. And likewise, when you integrate sine, it actually goes back to negative cosine, right? Because the derivative of negative cosine would be sine. So there's a few other trig rules here. Some inverse trig, just inverse tangent and inverse sine. As well as exponential, 1 over x goes to logarithm. And of course, just this one's a fairly standard one, just the idea that x to the n, you increase the exponent by 1 and you divide by the new exponent. So they'll give you lots of integrals that might at first look like they don't fit one of these rules. So they might give you something like x cubed plus 2x plus 4 all over x. And this does not look like any of the basic ones that we have here. And you might be thinking, I need some sort of like undoing the quotient rule kind of thing. But really you don't. What you need is some algebra. So first of all, we'll work on transforming the integral. Keep in mind you can split this apart into 3 separate fractions. And 4 over x dx. And 2 of these fractions, at least I'm going to simplify a little bit. So I'll take it one more step before I even start trying to do any calculus. So this would be x squared plus 2. This last one I'm just going to write as 4 times 1 over x. You might not need to actually write it out that way, but that's how we'll think of it. And now the integral is pretty easy to do here. X cubed goes to, or sorry, x squared goes to 1/3. So now we're actually integrating. Goes to 1/3 x cubed. 2 goes to 2x. The 4 is a constant multiple, so just like for a derivative, it sits there when you integrate. And keep in mind that 1 over x goes back to natural log. So we'll get natural log of absolute value of x. That's natural log. And formally, each one of these 3 things got a plus c on it. But we can combine all 3 of those plus c's and just put 1 plus c on the ends. And it looks like I wrote a little plus right there, which is not true. It's 4 times the natural log of x, just like it was 4 times 1 over x. A constant multiple just sits there when you do a derivative, and it also just sits there when you do an integral to go back the other direction. So this is the basic idea for an indefinite integral. If someone had given you a definite integral, if they had made this original problem, what would I say, like something like 1 to 5, then you'd go back to your answer and you would plug in 1 and plug in 5 and subtract the results. But for the moment, I'll just keep it as an indefinite integral. I'll say no 1, no 5, and then we'd be done with that. Okay, we'll do a couple more examples in the next video.